This course will teach you how the SC500 solution system and scrub system work. You will learn about the components that make up the systems and how they work together to accomplish their desired task so that you will be prepared to effectively troubleshoot any issues that may arise with these systems. After successfully completing this lesson, you will be able to describe what is unique about the solution flow rate on the SC500. Identify and explain what the water level sensor is used for. Explain how to test the water level sensor input. Explain how solution flow is regulated. Recognize normal brush deck actuator operation. And explain how the function board properly positions the brush deck actuator. Let's get started. The major components of the solution system are the solution tank, the solution tap, the solution filter, and the solution solenoid. During scrubbing, the solution flows by gravity out of the tank through the solution filter and to the solenoid valve. The function board turns the solution solenoid on and off to regulate the flow rate during scrubbing. The solenoid valve is spring-loaded closed to shut off the flow. EcoFlex models pump detergent into the solution system plumbing. Rather than regulating the solution flow rate based on time, it's regulated based on distance traveled by the machine. The purpose is to provide a more efficient use of water by providing a consistent amount of fluid on the floor according to the area that is being cleaned. This means that when traveling at a slow rate of speed, the solution flow rate will be reduced. And when traveling at a higher speed, the flow rate will increase. Although this may not be noticed by the operator, it's important that you know about this as the tech and understand that it's normal and expected behavior. Otherwise, in the event that your customer questions you about it, you might be trying to fix a problem that I'm connecting my voltmeter leads across the solution solenoid wires at the function board. When I operate the scrub system, note the click sound when the solution solenoid turns on and watch the voltage on the meter. The voltage pulse is pretty quick and the meter reading lags behind the click of the solenoid. The function board provides a I'm connecting my voltmeter leads across the solution solenoid wires at the function board. When I operate the scrub system, note the click sound when the solution solenoid turns on and watch the voltage on the meter. The voltage pulse is pretty quick and the meter reading lags behind the click of the solenoid. The function board provides a constant positive power supply to one side of the solution solenoid winding. The voltage goes through the winding to a switch inside the function board. When the function board wants solution to flow, he simply closes the switch to complete the circuit to battery negative, which energizes the solution solenoid. This is what the water level sensor looks like. This side is the side that senses the liquid level. It has a 3-wire connector. Notice that the mounting location of the water level sensor is right at the half-full line. The water level sensor input is used to even out the solution flow rate when the tank is below the half-full mark. Since the solution flow rate is determined by gravity, the flow rate will decrease as the tank level drops, as indicated by this line on the graph. Because of the water level sensor input, the function board can increase the on time of the solution solenoid when the tank is less than half full to even out the flow rate. Now the flow rate for the last half of the tank looks like this. The flow rate for the last half of the tank looks much the same as the flow rate for the first half. This solution tank is only 1/4 full, while this solution tank is full. Watch the difference in water flow rate when I remove the hoses to drain the tanks. The flow rate from the full tank is noticeably more than the flow rate from the tank that is only 1/4 full. The water level sensor is a capacitive sensor. It creates a field that is looking for the presence of a liquid. When the liquid enters the field, it changes the capacitance, and that change is seen by the sensor. The water level sensor is a 3-wire capacitive sensor that acts as a typical low-side logic switch. The switch is normally open. The sensor requires a power supply to operate, which is provided by the function board. Both a positive 24 volts and an internal connection to battery negative. The function board sends out a positive 5-volt supply through an internal resistor to the switch inside the sensor. When the switch is open, the input voltage matches the source voltage of 5 volts. When the water level reaches the sensor switch closes, which drops the input voltage to 0 volts. One of the really cool features of the SC500 is the ability to see the water level sensor input as seen by the function board just using the control panel of the machine. Let me show you what I mean. One of the really cool features of the SC500 is the ability to see the water level sensor input as seen by the function board just using the control panel of the machine. Let me show you what I mean. When you insert the super user key, down here on the corner, this little asterisk will be either an asterisk or a 0, depending on the input of the water level sensor. A circle means the sensor input is reporting less than half full. An asterisk means that the sensor input is reporting more than half full. Let's take a look at the solution level on this machine. And we are definitely more than half full. We're above 3/4. So that is a believable input. You could validate that the input changes by draining the tank, and in this case, when it went below a half a tank, this asterisk should change to a circle. But there's an easier way to do this. If you take the water level sensor here, if you put your hand over it, you simulate that the tank is over half full. If you take your hand away, you simulate that it's less than half full. So as I put my hand on it, it shows an over half full signal to asterisk. As I remove my hand, then it shows the circle. Let me show you again. I'll put my hand on it, we get the asterisk. I remove my hand, we get the circle. In the event that the sensor input does not change on the display screen, you will have to determine if the problem is the sensor, the wiring, or the function board. You can do this using a voltmeter. Remember that the function board supplies a 5-volt feed through a resistor to the sensor. And then the sensor takes that and switches it to battery negative to drop that 5 volts to 0. So let's get a voltmeter out and we'll test the sensor input. Sensor input. This is the sensor input wire here. I have a good sensor, so when I trigger it by putting my hand on it, you can see that the voltage drops to 0. So this is working as it should. But what if there's no change? Is the sensor faulty? That depends. If he isn't doing his job, you need to determine whether he has everything he needs to do his job. If he does and he still won't do his job, he needs to be replaced. So what does he need? Well, he needs power on the brown wire from the function board. So let's check that. Okay, there's a power supply. We got almost 23 volts. He needs the 5-volt supply to do the switching, which we've already seen he has here. And thirdly, he needs a connection to battery negative on the blue wire. And we have a good connection. We're comparing battery negative to battery negative, so we have 0 volts. If it makes you more comfortable, we could measure from battery positive and then check to see if we have a good negative. Here, the voltmeter. Comfortable, we could measure from battery positive and then check to see if we have a good negative signal here. The voltmeter reads full battery voltage. So we have our battery positive feed, our battery negative, and the you can also do the sensor's job, which is a switch to battery negative, and then check to see that the display changes when you do the sensor's job. So I have the 5-volt supply coming from the function board, waiting to be switched to battery negative by the sensor. I can do the sensor's job by jumping it to battery negative, and you can see that the voltmeter responds and drops to 0. Now let's take a look at the display. You can also do the sensor's job, which is a switch to battery negative, and then check to see that the display changes when you do the sensor's job. So I have the 5-volt supply coming from the function board, waiting to be switched to battery negative by the sensor. I can do the sensor's job by jumping it to battery negative, and you can see that the voltmeter responds and drops to 0. Now let's take a look at the display. Okay, right now it's not jumped to battery negative. I'll jump it to battery negative, and you see it goes to the asterisk. I'll release the connection to battery negative. It goes 0. So you can substitute the sensor's job with the jumper wire and confirm that that wire and the function board, everything is working as it should. The detergent pump is a solenoid-driven diaphragm-style pump. The function board cycles it on and off. The detergent pump is a solenoid-driven pump. The solenoid is energized to pull a plunger against spring pressure. When the solenoid is de-energized, the spring forces the plunger back. The cycling of the plunger creates the pumping action to inject the detergent into the solution system plumbing. The electrical circuit is essentially identical to the solution circuit. The function board provides a constant positive power supply to one side of the detergent pump solenoid winding. The voltage goes through the winding to a switch inside the function board. When the function board wants to energize the detergent pump to pull the plunger against the spring pressure, he simply closes the switch to complete the circuit to battery negative, which energizes the solenoid. Opening the switch de-energizes the solenoid to allow the spring to force the plunger back. You can use the detergent draining feature to force the detergent pump to operate for troubleshooting purposes. The instructions are in the operator's manual. Normally, once you're in the drain function that you're here now, you should see drain on the display and hear the detergent pump cycling on and off. If you don't hear the pump cycling on and off, then you can check with your voltmeter to see if you have any voltage here. But it's going to be very fast. It's just going to barely blip your voltmeter. So if you had an LED type of test light, that might work better. But using that drain function puts it in a mode where it'll make it easier for you to test this.